All right, ladies and gentlemen, let's give word problems a second go around. We're looking at the second lesson here. There really isn't necessarily anything that separates A from B, other than we've got so many different ways of looking and thinking about our problems that we wanted to divide them into two lessons. You do notice different here is that there is a spot for a diagram, because sometimes drawing a picture of what's going on becomes incredibly helpful. So we have a carpenter building a rectangular fence for a playground. One side of the playground is the wall of the building that is 70 feet wide. He plans to use 340 feet of fencing material. What is the length of the fence if the width is 70 feet? So I do want to define a variable. All right, L is going to equal my length. That's what we're trying to find. That's what we don't know. So we're going to take a look at our diagram. We have a rectangular fence around a playground. And one side of the playground is the wall. So I'm going to have the wall here. It doesn't matter where you put the wall. I'm putting the wall here. And so what that means on my playground is that the fencing, it's rectangular, but it's only going to have 3 sides, because I'm not going to put fencing up against the building. 1, it would cause problems getting in and out, and 2, it's a waste of materials. So we have a 70-foot wide wall. This is 70 feet here. And those of you who took geometry last year remember things from geometry. In a rectangle, opposite sides are equal. So if the wall is 70, that means the amount of fencing across from that is 70 feet also. We then have our unknowns, our lengths. So I'm going to put L here and L here. So let's take a look at the equation. We have this total amount of fencing. We have 340 feet. And that 340 feet, it's kind of like the wrapping box problem. It goes around 2 L's and then a 70-foot section, and that equals our 340 feet. So we can go through and solve. We subtract 70 from each side. We go through and divide by 2 on that. And we get a length of 135 feet. Notice we have labels. Let's not leave those off. We're being complete and thorough in our problem solving. All right, we've got another rectangle problem. So once again, we're going to try and draw a diagram. It says the length of a rectangle is 4 meters more than the width. The perimeter is 132 meters. Find the length and the width. We have to find both of those. Well, I'm not going to be able to define L and W. I can't use 2 variables. But what I am going to do is draw my rectangle, and then I'm going to go through my problem. It tells me that the length is 4 more than the width. Length, I always have running across my paper from left to right. So that means this is my length, and this is my width. But what I know is that my length is actually 4 meters more than my width. So that means this side is 4 meters more than my width. My width doesn't have anything special about it, so this W is going to come out here, and this W is going to come out here. We know the perimeter is 132 meters. Well, we already said earlier in this chapter that perimeter is 2 lengths plus 2 widths. So we have 2 lengths, so 2 times the length plus 2 times the width. That equals our perimeter of 132. We distribute, we get 8 plus 2W plus 2W equals 132, or 4W plus 8 equals 132. So that's one way of using our perimeter formula and getting ourselves an equation. The other way is to look at what's going on in the problem. I have 1, 2, 3, 4 W's. I have 4 plus 4, and that gives me 8. So the second way in blue is visualizing what's happening. It's actually going around this rectangle and adding up like terms, adding up all the sides. Well, now regardless of which equation you write, or the way you write your equation, they end up being the same, we're going to now solve them. And we are looking at meters. So the width is 31 meters. Notice I'm going to go back and look and see what they told me to do. They told me to find length and width. So I need to have what L equals. L is 4 more than W. So length is 35 meters. All right, one last example. Courtney and Haley measure themselves and find that Courtney's height is 6/7 of Haley's height. Now remember, guys, we talked about this. It is 6/7 times Haley's height. That's what we know about Courtney. The sum of their heights is 130 inches. So we know when we add the two girls together, we get a total of 130 inches. So Courtney, we said right away, was 6/7 H. Haley, they don't give us a value, so has to stay H. So our equation here is 6/7 of Haley plus Haley equals 130 inches. We're going to add those together. You've got a couple of options. Use your mental math, use your calculator. But you're going to get 13/7 H is equal to 130 when you add 6/7 plus 1. Divide by 13/7. Use your parentheses. And we're going to have H is equal to 70 inches. So that means Haley has a height I want to stop and think, does this make sense? Well, 70 inches, if I divide that by 12, that gives me 5 feet and 10 inches. 5 feet 10 inches is a tall girl, but it's not abnormally tall. This answer seems reasonable. I now need to find Courtney. Well, Courtney is 6/7 H, would be 6/7 times 70. That'll give me my Courtney height. And so 6/7 times 70 gives me 60 inches. And those both seem reasonable. If we look, 70 plus 60 does equal the 130. All right, hopefully this is a little bit better than last night's. Have a good evening.